In this lab, we were learning different techniques for LiDAR and DEM data. We use Viewer as our LiDAR program and QGIS for our DEM 3D model. This lab was broken down into the two programs, and I'll start with our LiDAR models. LiDAR is a type of data collection that uses a laser to pulse over an area and measures the reflected pulses for size and distance. LiDAR is essential to 3D modeling of structures because it provides depth to initially 2D images. In Lab 4, we used point data that was given by VGI with a geographic location. And this is different from LiDAR because the data was given by citizens, in our case, our class, and the points were specifically chosen for a purpose, while LiDAR is typically a company or a group looking for specific data obtained through larger sweeps of aerial surveys. Point data also creates 2D maps, while LiDAR can create 3D images from the information it gathers. So looking at our first LiDAR model, here we see the bank of the Mississippi River as seen from downtown Minneapolis. Viewer is not available on Mac, so we'll just be looking at a 45-degree angled screenshot of the 3D model. And we can see that the buildings here have a depth and are geographically oriented along the river. And so you can see that even in this screenshot that there is different levels of depth and different topographies. So then if we zoom in on this building right here, we took a cross section of this building to create our second LiDAR model. And this transect shows the building we chose as well as the bank of the river in purple and the next door buildings to the left. But this building right here is the one that we were tasked with identifying. So based on its location and architecture, we found that this building was the Guthrie Theater. It is an icon in Minneapolis that is known for creating a welcoming theater experience for the community right on the Mississippi River. Founded in 1963, this theater tries to mix traditional and classical plays and musicals and is important to the art scene of the Twin Cities. So it's quite an important and well-known building in Minneapolis. So we had to measure this building using the Viewer program. And when I used the measuring tool, I measured from the bottom of the building marked by the horizontal purple to the top, not including the antenna. And I got a value of 51.08. I then took this value and looked through the metadata provided by Minnesota Geographic Metadata Guidelines, and that stated that 1.5 points is equivalent to 1 square meter. So I took my 51.08 value in points and divided it by 1.5 to get a building height of 34.05 meters, which is roughly 111 feet or 10 stories tall from base to top. So now we move into the DEM portion of the lab. DEM stands for digital elevation model, and it is mainly used for topographical maps of like a planet, moon, or asteroid, or just kind of rural areas. DEM uses similar technology to LiDAR, but it simply maps the elevation of an area rather than the structures. Buildings can be added, as it is seen in our lab, but the physical landscape is the main focus. So we created a model of the Coweta Lab in QGIS. And if we zoom in right here, we can see the depth of the program and the colors. So they represent the different elevations. So here's the depth of the program. And again, this was not on Mac, so it couldn't get moved around in a 3D way. But it shows the fact that this is represented in a 3D model, and then the colors represent the different elevations, with the lighter colors meaning higher up, and the dark colors meaning the lower elevations. And then we added the buildings of the Coweta Lab, as seen in the red here. And we added those by putting in the base elevation, and then the top elevation of that building, since this uses elevation as its mapping. and it would place the structure in that location. So for using these in real life, in space exploration, DEM is incredibly useful to map the surfaces of topographically varied areas. So when planning the moon landing or knowing the exact elevation, it was necessary for being able to land on the surface. It can also be used in the future to continue moon exploration, as well as extending it to other planets such as Mars or Venus that have rock-based surfaces. So programs like NASA and NOAA use DEM on a regular basis for planning missions, either remotely or manned. Um, and it's a great tool to be able to create 3D models such as this for places that we don't actually have on the ground imaging for. So this has been Lab 5 for Intro to GIS, and that's it.